With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, I am your teacher for this question, and the question is 10 liter of hard water require 5.6 gram of lime for removing hardness. Hence the temporary hardness in ppm of calcium carbonate is. So in this question it is given that the volume of hard water is 10 liter and it requires 5.6 gram of lime, that is calcium oxide, for removing hardness of water. So the temporary hardness in parts per million is. So first of all, what is the hardness of water? Hardness of water is due to the presence of the bicarbonates of calcium and magnesium ions. Hardness of water is due to bicarbonates of calcium and magnesium ions. And this hardness is removed by adding calcium oxide in the hard water, so that the bicarbonates present in the water will form the carbonates, carbonate precipitates, and hardness is removed. So hardness of water in ppm can be calculated as mass of calcium carbonate to the mass of water into 10 raised to power 6. So it will be calculated in ppms. So now what is the reaction then? Calcium bicarbonate plus calcium oxide, it will form calcium carbonate precipitates plus water. If the precipitates will form, the hardness is removed. So now from this reaction, firstly we will balance this reaction as 2 calcium carbonates. Now this is the balanced equation. It means 1 mole of calcium oxide, 1 mole of calcium oxide or lime is required to precipitate 2 moles of calcium carbonate. 1 mole of calcium oxide is required to precipitate 2 moles of calcium carbonate to precipitate. Now in the question it is given that the weight of lime is 5.6 grams. So we can calculate the moles of calcium oxide or lime. Then moles of calcium oxide or lime will be its given weight, that is 5.6 gram, divided by its molecular weight, that is 56 gram per mole. Molecular weight of calcium oxide is 56 gram per mole. So now the moles will be equal to 0.1 moles. Now if 1 mole of calcium oxide is required to precipitate 2 moles of calcium carbonate, so if 0.1 moles are present, it will precipitate 0.2 moles of calcium carbonate. It means moles of calcium carbonate precipitated will be 0.2 moles. Now if we have the moles of calcium carbonate, we can calculate the mass of calcium carbonate. Mass of calcium carbonate as number of moles is equal to given weight upon molecular weight of the substance. Here the weight we have to calculate, number of moles are 0.2 moles and the molecular weight of calcium carbonate is 100 gram per mole. So the mass will be number of moles multiplied by molecular weight. Number of moles is 0.2 mole and 100 gram per mole is its molecular weight. So it will be equal to 20 grams. It means mass of calcium carbonate is 20 gram. Now to calculate the hardness, we have the mass of calcium carbonate, but we have to calculate the mass of water. So it will be, as the volume of the hard water is given and we know the density of water is 1 gram per ml, so we can calculate the mass of water. So mass of water will be equal to as density is equal to mass by volume. So we have to calculate mass, so we multiply density by volume. Now mass of water will be density into volume. Its density is 1 gram per ml and volume is given 1 liter. So 1 liter will be equals to 1000 ml. So the mass of water will be 10 liters. So it will be 10 raised to power 4 grams of water. So now we will calculate the hardness of water. Hardness of water in ppm. It will be mass of calcium carbonate, that is 20 gram, to the mass of water, that is 10 raised to power 4 grams, into 10 raised to power 6 to calculate in ppm. So it will give us 20 into 10 raised to power 6. This will go in numerator and form 10 raised to power minus 4. So it will be 20 into 10 raised to power 2, which is equals to 2000 ppm. So the hardness of the water due to calcium carbonate or hardness of calcium carbonate in ppm is 2000 ppm. So I hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.